All right, so if you take an ester, so the ester is one of our functional groups that doesn't react fast enough with weak nucleophiles to be practically useful. So our ester is pretty stable. Our alcohol as a nucleophile is pretty weak. So combining the two things together doesn't do a whole lot. If you mix in some catalytic acid, sulfuric acid works in this case, then you can get the new group here. Right, so our alcohol, our propanol here, 3 carbons, can be added on and make a new ester, right? So that's why it's called trans-esterification. We're swapping one ester for another, the methyl ester to the propyl ester. So without the acid, that's not going to work. And it's a multi-step mechanism. It's fairly long, but essentially it's still going to follow the same usual steps where the nucleophile adds and then we eliminate a leaving group. The key difference is that along the way, anytime we are making those major changes, the groups need to be protonated, right? In order to react, it's going to need an extra proton on there to activate it. In order to lose a leaving group, it's going to need an extra proton. So there's a lot of extra proton transfer steps. But fundamentally, we're still doing the same mechanism. So again, we have our ester, we have our protonated alcohol. So if you mix in a little bit of sulfuric acid with your propanol, then it's going to protonate that propanol in order to react. Right? And you might think to activate here, because that's the group we need to come off, but actually for the nucleophilic addition step, the important group is that oxygen. So for the nucleophile to add to the carbonyl, we'll activate the carbonyl oxygen first. All right, so now we have our ester, but it's activated now. So it's going to make it more reactive to our weak nucleophile. Right, so that's our typical nucleophilic addition step. It just required an extra proton transfer first to get it started. Right? And then now we've started the reaction. Right? And our new group on here, the propyl, though, has an extra hydrogen. So we'll remove that. Right, so what have we got left to do? Right, so activated the carbonyl, did our nucleophilic addition, so our new group's on there. Right, our new group still had an extra proton, so we remove that. Right, so now our propyl, which I had circled in green, is attached, but I still need to remove this other original ester as a leaving group. So in order to do that, though, it needs to be activated first. Right, so again, there's a lot of steps, and we're not done yet, but I needed to activate the carbonyl to make this reaction happen. Right, then clean up with an extra proton transfer. I need to activate this extra methyl ester, because otherwise it's not going to be able to be removed. Right, now that could come off as a leaving group. So how are we going to accomplish that? Right, so our first step, nucleophilic addition, right? Then usually what happens is you reform the carbonyl and kick off the leaving group. All right, so let's do that. All right, I'm feeling like it's pretty close. Right, so I'm really close to my ending structure here now. I've just got the extra proton up on the carbonyl, and that can go away with another proton transfer, right? So our acid was catalytic, right? So if we regenerate our protonated alcohol, that's probably going to make it work and be catalytic. Draw a little border there. So yes, this is a lot of steps, right? So start intermediate 1, 2, 3, 4, 5 intermediates before I got to my final product. The key steps of reactions of our carboxylic acid derivatives are still here though, right? So if we look, here's our nucleophilic addition, right, where our nucleophile added to the carbonyl. It just needed to be activated first because this is a weak nucleophile, right? Here is our elimination step, right? So the lone pair of electrons up on oxygen reform the double bond, kick off a leaving group, getting us back to where we wanted to be, right? So these two steps are still there. Everything else is proton transfer. We needed the first one to activate the carbonyl, second one, to clean up the leaving group, right? We needed this proton transfer here to activate our methyl ester leaving group, right? We needed to get rid of this extra group, but it needed to be proton transferred first so it could come off again, right? And then another cleanup proton transfer. So there's a lot of protons bumping around back and forth, and then it ends up back onto the original alcohol like we started with. So a lot of color there, a lot of steps, but it's mostly we're looking at the fundamental idea that these functional groups need to be activated by the acid in order for them to react. And also, since the ester has such a bad leaving group for these reactions, that needs to be activated as well in order to make the reaction work.